Hey there, this is Horner, and we are looking at gravity and Coulombs law. Free response question number one. Somewhere in space, far from other masses and charges, two very small, dense circle objects, one or two, are initially at rest, and they have centers that are separated by 3 meters. So here's number one, here's number two, and then the separation distance is 3 meters. They give you the masses of both of those spheres, and they give you the charges. Notice that both the charges are positive, so these two things should repel each other. So the force of electricity should be pointing away from each other, which we'll see happens in the diagram down on the bottom. And because they both have mass, they are attracted to each other because the force of gravity always pulls things together and never pushes them apart. They want to know, calculate Fg, and they want us to calculate Fe, the gravitational force and the electric force acting on sphere number one. So when we do the gravitational force, we're just going to take the universal gravitational constant, which is 6.67 times 10 to the negative 11th, and multiply that times mass 1, and then times mass 2, which they've given you here, and then divide by the separation distance squared. And remember, this is 3 meters, not 3 centimeters. So I'm going to get rid of the 0.03, and this really should just be 3 squared. When we do that, we end up with 10 newtons here. And then for the force of electricity, we're going to use the force of electricity equation. Fe is equal to K times Q1 times Q2 all over R squared. And when you plug all the numbers in from what they gave you here, you will get 20 newtons. So you're going to notice that the electric force is double the force due to gravity. Since that's true, when you draw your diagram, we're going to do 1, 2, 3, 4 lines over for electricity and 2 lines to the left for gravity for this charge, and then the opposite for this one, 2 to the right and 4 to the left here. And that would be the only forces acting on each one. For the next part, this one says you are analyzing the situation, and when you see that they are 3 meters apart, the force is twice as big, so we see that. How far apart must the spheres be separated in order for the gravitational electric forces to balance? They will never balance. Here, you have to just remember that the force of electricity is, that's really is, always 2 times the force of gravity in this situation. Regardless of the separation. So once you have this ratio, that ratio will not change. If you calculate the ratio like we did here, then it won't matter the separation distance, because notice that these are the same on the bottom. If we change these to 6, everything on the top stays the same, as well as our constant. So you're always going to have that 2 to 1 or 1 to 2 ratio. And that is the end of this very simple problem.